All right. In this lesson, we're going to learn how to solve for x in similar triangles, or similar figures, I guess. Solve for x in similar figures. So we're going to know that each pair of figures that's given to me is similar, and we're going to use equivalent ratios to solve for x. So example 1. Oops. Sorry. Okay. Example 1. So I'll do this two different ways. So let's do it one way using the scale factor method. We'll do one way by working with scale factors, and we'll do another way with equivalent ratios. Okay, so one way with scale factors is to first just start by finding my scale factor. So I can see that the 3 and the 18 line up. So using those two, I can find my scale factor. So 3 times what is 18? Well, 18 divided by 3 is 6, so my scale factor is 6. So what that means is that for my unknown side, my scale factor has to also be 6. So I'm going to start by saying what number times 6 gets me 48. So 48 divided by 6 tells me 8. And now, sorry, that's messy handwriting. And now that I know this side has to be 8, I can just make a little simple equation that says x minus 4 equals 8. So solving that out, x equals 12. So that's the scale factor method. It works really nicely when your scale factor is just a plain old whole number. The equivalent fractions method means I'm going to make a ratio from these sides and a ratio from these sides and equal them to each other. So I will just say x minus 4. So the ratio from this side to this side is the same as ratio from this side to this side. And then this one, we can solve it out by, we can solve it out with the method we learned in class yesterday. Just multiply both sides of the fraction by each other's denominator. So 18x minus 4 divided by 54 equals, I think that's 144. Let's see, 48 times 3, 144. Great. 144 over 54. And so then I have 18x minus 72 over 54 equals 144 over 54. Now I can ignore my denominators. And let's see what I end up with. Plus 72 equals 216. And then divide that out. 216 divided by 18. And I get 12. So you can use whichever method works for you. The scale factor method is really fast when there's a nice and easy whole number scale factor. But equivalent ratios works if the scale factor is like a different, weirder number. Okay, we're going to do, I think, 3 more examples till those make a lot of sense. So take a minute. This one, why don't you take a minute and try to solve this one, whichever way you like better. I'll help you by seeing that I have my scale factor. I can find my scale factor by looking at these corresponding sides. So take a minute and try to solve this problem for x. Okay, I'm going to just use the equivalent fractions method just because I think that's the method that's going to work better in the long run for us. So I'll say, and you could just set up your fractions by looking across the triangles too. So 5, so this side matches to this side. That ratio should be the same as this side to this side. So there's many other ways you could have set up your equivalent fractions. Like as long as the right sides are lining up to the right sides, you'll get the same answer. Okay, so let me solve this out. Oops, that's not what I want. I'm going to multiply by the other denominator. 2x plus 6 and 15. Okay, so, excuse me. So I have 5 times 2x plus 6 over, I'm just going to leave parentheses here because I don't need to figure that out. And then 6 times 15 is 90. Okay, so now I'm just going to make my nice and simple equation with my numerators. 5 2x plus 6 equals 90. 10x plus 30 equals 90. 10x equals 60. X equals 6. So hopefully, regardless of how you set up your equivalent ratios or if you use the scale factor method, you ended up with x equals 6. And I always like to just plug it in and see if it makes sense. So let's plug it in here. So 2 times 6 plus 6 is 12 plus 6 is 18. And look, it makes perfect sense because my scale factor I could see is 3. 6 times 3 is 18. So you can always, usually there's a way to check your answers if you kind of look back to the original diagram and plug stuff in. All right. I think we're going to just do 1 or 2 more trickier ones. And we'll practice it more in class. So this one is really wonky looking because they're not lined up correctly, but they're telling me what lines up right here. So DEF is similar, this symbol is similar to DVW. So let's see. So that means DE lines up with DV. So those two sides line up. And then let's see. Then that means that DF must line up with DW. So use the similarity statement to see which sides correspond to which sides before you set up your equivalent ratios. So you could do 11 over 30. You could do 11 over 10. Actually, why don't I do it that way? I could say 11 divided by 10. Or no, I'll say 11 divided by 33. So, sorry. So 11 to 33 has to be the same ratio right here. Again, this is a nice one to use scale factor on as well, but I'll just keep going with equivalent fractions to stick with that one method. So 11, or let me do it the other way. 33 to 11 is the same as 8x minus 2 to 10. So if you haven't already, well, why don't you solve this by yourself if you haven't finished solving this problem already? So I'll multiply this by 10 over 10. So I have 330 and I end up with 88x minus 22. So let's see. 330 plus 22 is 350. So 352 equals 88x. Great. And so x equals 4. Let's just see. Let's just check it to be thorough. So if I put 8 times 4 minus 2, I get 30, and that's 3 times bigger. Okay, I'm going to give you guys one last one to try to solve on your own, just to have a little bit more practice before we work on these on the warm-up tomorrow. Okay, so take a minute, pause the video, and really think about how do we set up our set up our equivalent fractions and solve for the variable. Okay, so let's look at this now. So HG lines up to HQ. So HG and HQ line up. So this time it's kind of flipped around. And then FH will line up to HR. So let's set up our ratio. I can say 72 to 27 is equivalent to 5x minus 1 to 24. Okay, so this one doesn't seem like a great example for a scale factor because it's hard to know how to get from 72 to 27. But I can just solve this out with my equivalent fractions. Just need a calculator since the numbers are a little bit annoying. 24 times 72. And my denominator is 648. Oops, oof. Okay, so now let's make my easier equation with my numerators only. 1,728 equals 27 times 5x minus 1. And then if I finish solving that, let's just do it all in one step. 1,728 plus 27, and then divide that by 135. So you should end up with x equals 13. So even if you set up your ratio in a different way, you will still end up with x equals 13 to make equivalent ratios. All right, we'll practice those a bunch more in class, and we'll talk more about different ways to set up ratios as well.